On an individual basis, the probability that one passenger will miss a flight is 0.0932. Airlines do not like to fly flights with empty seats. You're going to lose money that way. So maybe they sell more tickets than they have available seats. Take, for example, here, if there is a flight with 53 seats, then if we were to divide 53 by 1 minus 0.0932, not that this is anything that they're asking for, but let's make that a little easier to read here. So divided by 1 minus 0.0932. And maybe they're willing to sell 58 or 59 tickets, since they know on an individual basis, people are missing flights 9 or 10% of the time, roughly. I just rounded that 0.0932 and converted to a percent there. Okay, well, let's see here. Let's say they sell 55, even though they only have 53 seats. Then what is the probability of someone let's say they have 54 or all 55 show up when they only have those 53 seats, which would mean that either 1 or 2 people are going to get bumped from the flight. In an earlier video, I showed the use of the following formula. What you would want to do in this case is have 55, choose 54 times 0.0932 to the 54 power times 1 minus that 0.0932 to the 1 power, and then add to that 55, choose 55, 0.0932 to the 55 times 1 minus 0.0932 raised to the 0 power. I'm going to use something quicker though, that I also showed in an earlier video. We can use the binomial CDF. Now, let's see here. Let's double check what we were asked for first of all. The probability that X equals 54 or 55, 55 being the maximum value because they're selling 55 tickets. That's how many are showing up. The complementary event would be that X would be less than or equal to 53. And so we could take that probability, subtract from 1. And I don't want to have to add up the probability from X equals 0 up to the probability that X equals 53. So I'm going to use the binomial CDF. And that's going to be 55 trials. Probability of showing up, because that 0.0932 was the probability of missing the flight. So this would be the probability of not showing up. And we're going up to 53. Now you can compute what this is equal to before you put it in, or you can just put it in the calculator this way. So let's see here. Second bars down to binomial CDF, and let's make it so we can see both at the same time if possible. Well, let's see that. All right, and then the calculator. You'll see that as well. All right, first of all, I could do the binomial CDF and then subtract from 1, but I want to put it in all at once the way I've written on the paper. So 1 minus binomial CDF, second in bars, oops, second and bars. Go. So 55 trials because they sold 55 tickets. 0.0932 was the probability of missing. We're asking about them all showing up. And we're only going to 53 because we're subtracting this from 1. 53 or less showing up is the complementary event of 54 or all 55 that were sold a ticket showing up. And that's going around 0.0306. I bet they wanted to 4 places. Let's see. Yes. All right. Probability the passenger will have to be bumped is, that should be the same thing. Because we just talked about 54 or 55 when they only have 53 seats. 0.0306. Give me a moment here. Okay, sorry about that. In part B, now they're selling 59 tickets. So since they only have a capacity of 53, let's change that 55 to 59. Try putting in 0.05250. Okay, got to read more carefully sometimes. Okay, then they changed the number of seats again to 270. And they want to keep the probability of someone being bumped below 1%. Now, this is going to take some trial and error. I'm going to divide 270 by 1 minus 0.0932. And guess that maybe they'd be willing to sell 297 to 298 tickets. But if I put that in up here, let's go with the 297. $297. That's a virtual guarantee that someone will get bumped. So let's try going somewhere between 270 and 297, say halfway in between. Getting 283.5. How about I round that down to 283? Still too high. Remember, as a percent, that is 100%. We want it below 1%. Okay, so let's go halfway between 270. Oh. Sorry. I should have been changing this as well. That 53 is now 270. Okay, well, that's more than 41%. So now let me try to go to 283. That 9 is not going to show up until 4 places after the decimal point. And then if I convert it to a percent, that would be about 0.10%. We want it less than 1%, which it is, but can they push it higher? So I'm going to go halfway between the 283 and the 297. I get 290. See how that compares. As a percent, I'm multiplying by 100%. That's above 1%. So let's go between 283 and 290. I'm getting 286.5. So let's see about 286. That's below 1%. Be 0.78%. Let's go up to 287 and see if it's still below. Nope, just went over. So we'd have to stick with 286. They're willing to sell 16 extra tickets. All right. That is it for now. Hope that helped.